Hello guys, in this video, we will build a machine learning system that can predict big market sales. Let's see our problem statement. There is a grocery store company that has several outlets or several stores around the world. They want us to predict the sales which they can expect. So what is the application of predicting these sales? What can happen by predicting these sales? With the help of prediction, we can predict revenue, and what are the challenges they may face, and what are the brands they can also what are the brands and what are the products that sells the most, and other such kind of things. So they can also make several marketing plans, which product is selling the most, and etc. So this project is a regression based machine learning project. Machine learning is generally classified into supervised and unsupervised learning. So in supervised learning, we can train our machine learning model with labeled data set, whereas in unsupervised learning, we train the model with unlabeled data set. So in this project, labels are the targets, that is the sales cost. Here we are using the regression where we predict continuous value. We are predicting the sales. So let's understand the workflow. So first we need to get the data for this project. We are going to use big market sales data. So once we have this data, there are a lot of pre-processing to be done, like encoding the categorical features, etc. After that, we need to analyze the data. It is called as exploratory and data analysis, where we put the data in some suitable plots and graphs, and see what are the distribution of various data points, and what is the count of various features, and such kind of things. So this helps us to find the meaning the data has to tell. So once we complete this task, we will split our data set into training data and testing data. In machine learning, we train our machine learning model with training data, and we test or evaluate it with the test data. Once we split the data, we will feed our training data to our machine learning model. In this project, we are going to use regression model. So the regression model is our XGBoost Regressor. So once we train our model with training data, we will evaluate our model based on the test data. So let's get started with the coding part. So we will be doing our coding in Google Collaboratory. So first I will upload my dataset here, and just right click and click on upload, and it will direct you to upload from your local system. And I will provide the dataset link in my description box. So let's proceed. So let's start by importing all the dependencies. So import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import cborn as sns. So from sklearn dot preprocessing, import label encoder from sklearn model selection. We'll import XGBoost. One. So we are good. So like NumPy as NP, so it is useful for making NumPy arrays, and pandas, it is useful for creating pandas data frame. And matplotlib and seaborn it's used for data visualization. It's like our data visualization library, so useful for making plots and graphs. So like this sklearn library is one of the very important library where we get several models and pre-processing functions from it. So from there we are importing level encoders, and we will import the train trace split and so Big Mart. pd.read csv. So we have loaded our data from CSV file to pandas data frame. So now let's check the first 5 rows of the data frame. So you can see the first 5 rows of the data frame. So it has a identifier. It's these are like identification numbers. Like FDA indicates like something related to food, and DR related to something related to drinks, and C like it is a non-consumable item. So these are the our data set. So like this outlet identifier, and different states have different outlet identifier name. So, let's proceed with let's check how many data sets are there. So how many there are the how many number of data points and the number of features. So Big Mart data dot shape. So you can see there are 8523 data sets and like 12 columns. So let's get some more information about the data set. So like we can see that there are we have both categorical and numerical data set. So we have to process it. So let's check, is there any missing values or not? So like you can see that the item weight and the outlet size have some missing values. So we have to handle these missing values first. So like we will impute the missing value using the mean of this column, or like we can also impute by using the mode of that column also. So and we will be imputing the missing values by using the mean of those column. So item weight, so Big Mart data, to choose the item weight dot mean. So this is the mean. So now we will be filling the missing values in the item weight column with the mean value. Dot fill NA. Or Big Mart data, item weight dot mean. So in place equal to true. So like we will replace the item weight with the mean, the missing values of the item weight with the mean. And now there is another column, like there is this outlet size which have missing value. So let's replace those missing values of outlet size with the mode of the column. Of the outlet size. So let's check the mode first. It's showing 0. So we will fill the missing value of this outlet size column with the mode. So mode of outlet size equal to Big Mart dot pivot table value is equal to So we will run this and so we will print the mode of the outlet size. So we are using pivot table here. So this is the pivot table we are talking. We are taking two column like outlet size and the outlet type. So because these two columns are correlated, so four different out and there are four different outlet type. Um, so we are using this like and these two column are correlated. So for that we are using the pivot table. So if at all the outlet size would have been an independent column and it is not correlated with any other column, so we would have used only directly we have used the mode and replaced it with the uh, zero value. So as each outlet type is like depending on the outlet size and like outlet size is dependent on the outlet type also. So we have to use this pivot table concept. So we have used this lambda column, lambda function. So it's like anonymous function. So now let's check the missing values. Is there any missing values after like imputing? So miss values equal to. So we'll print miss value. So like it takes all the missing value, it will compare it with the output type and it will replace the outlet size depending on the outlet. So let's proceed. So like this statement, it creates a spreadsheet style pivot table as data frame. The labels in this pivot table will be stored in multi-index object. We are just getting some kind of a table where we want a particular columns. So now let's check for is there any missing values or not. So you can see all the missing values have been imputed. So now let's check for the description of our data set. So we'll use describe function to know more about our data set. So you can see that count, the mean, the standard deviation, the minimum, the 25 percentile, 50 percentile, 75 percentile, and the maximum. So let's proceed. So before that, we will do a SNS.set. So this SNS.set give us some theme for our plot. It will give some grades and other things. Once you run it, it will be followed in all the plots you make. So let's proceed with some data visualization part. So first we will see the item weight. So plt.figure fixed size equal to 6,6. SNS dot dist plot. So our item weight is a numerical column, right? So we will use this plot. If it would have been a categorical column, we would have used count plot. So item weight. So plt.show. So you can see that maximum value is is 12. This is the reason we are getting mean around 12. Before we have calculated the mean, so it was around 12. So this was the reason why we are getting our mean as 12. So you can see that using this graph, we can easily means it's so easy to comprehend our data. So let's proceed with let's see. Let's take the column of item visibility. So the same thing I will copy. Just I will change the item weight to item visibility. So item visibility. So this is also a numerical column. So we can see there is a little bit of skewness in the data. It means that the values are distributed more in one side of the graph. So the more value is distributed around is 0.05. Okay. So let's proceed with, let's take the item MRP column. So We'll copy it and place it with item MRP. So you can see that this is not at all a normal distribution. There is a peak in some products. So now let's proceed with, let's check what are all left. Is outlet establishment year. So like it is not required, like this will not be helpful for our model prepare training, so will not use this. So I will take this item outlet sale. So it's also kind of a skewed curve, so more are like in the beginning of the data set only. So let's check the like obviously we will also visualize this count year is this establishment year, but for this we can use like count plot. So though it's a numerical column, it can be, means some columns can be shown in the way of a categorical column, like because each individual year have like a particular count. So we will use a count column here. So instead of using the this plot, we will use the count plot for the outlet establishment year. So plt dot figure fixed size let's say 6 sns dot count plot. For x we will keep that outlet establishment year, and the data we will provide is our Big Mart data. Plt dot show so this is the outlet establishment year. Count of respective years is being shown. So our numerical part is done. So now let's move for the data visualization of the categorical part. So we'll see how many of them are categorical. So it's the item fat contain, and one is the item type, and our then outlet size. These are like our categorical columns. So let's check. So we for categorical column we can use count plot. So I will copy this, and instead of this and establishment here, I will use first. I will take that item fat content. This one. So you can see that item fat content and the low fat is highest, followed by regular, and LF, then low fat, and reg are almost a similar count. So let's proceed with the item type column. So item type. You can see this column for like better visibility. We have to increase this fixed size limit. Let's say 30. You can see that this item size like dairy, soft drinks, meat, fruits and vegetables, household holds and their respective counts. So now let's proceed to the data pre-processing part. Let's check the first 5 rows of the data set. So big data, Big Mart data dot head. You can see our first 5 rows. Now we'll check for the counts of each rows of item fat content. This one. So Big Mart. Item fat content. Can do this by using the value count function. So low, regular, LF, regular, low fat. So these are the respective counts. So we will replace this categorical value with some numerical value. So let's do this. So first we have this like low fat. So we will replace that with, we'll replace this 4 to 4 and 5, like this 2 by 2, only 2 values, means 2 categorical values. So replace low fat with capital low fat. This small LF. Low fat. Regular. So let's check Big Mart. Item fat content dot value counts. So you can see that previously we were having the low fat and the LF, which indicates the same thing, and this small low fat also. So we converted this 1, 2, 3 to capital low fat, like this with this kind of label. So and we this regular and REG indicates the same thing. So we chose this converted this small REG to regular. So that's why now we are having only two kinds of data inside this item fat content, that is low fat and a regular one. So let's proceed with the label encoding part, like all the categorical value and takes all the categorical value and transform it into numerical values. So let's proceed with that. So encoder equal to label encoder. So first I will take the item identifier. Big Mart data item identifier equal to encoder dot fit transform our Big Mart data and we'll take the item identifier. So similarly, we will be doing with the item fat content and with our item type, our outlet identifier, outlet size, outlet location type, and the outlet type. So we'll proceed with the same. Let's copy it. So we have like item fat content, copy it. So then we have the item type. So next we will have the outlet identifier. So next we have the outlet size. So the outlet location type. And finally, the outlet type. So here we were having some problem in our data set because this some outlet size had two kinds of value, like it was having a different data type. So we have to convert it the outlet size to string function. So the everything is being converted to as str. So like you can also now let's check the size outlet size column, so we can visualize it. So but uh, these columns are like the combination of float and string. So we have to convert it to as type str. So it was throwing an error. So now we have done that. So basically, what this encoder will do, it will take all the values and it will give one label to each of the unique values. So let's check the Big Mart data dot head. So you can see this item fact was a categorical column and now it is converted to a numerical column. So item identifier, like outlet identifier and all. So all of them have numerical values in it. So we will proceed with splitting features and target. Will drop columns equal to this item output sale is item outlet sale is our target column. So we'll drop this with axis equal to 1 and in y to take Big Mart data and we'll store that item output cell. We'll run it. So print our x value. These are our x values. Let's print our target value. These are our target values. So now let's proceed with the splitting the data into training data and testing data. So X train, X test, Y train, Y test, train, test split will give the X value, Y value, test size equal to 0.2 and let's take the random state as 2. So basically, the test size is equal to 0.2. It's like 20% of the data set is being used for the testing purposes, and remaining 80% of the data set is being used for the training purposes. And random state equal to 2. So like it is just used to reproduce the same code. Like mine data set and your data set will be split in the same manner, and we will get the accuracy, or our model training will be done in the same way. So let's check the shape of our x column, x dot shape, and x dot the training part, and tra and train dot shape, and the testing shape. So you can see originally we had 8523, and after training, after splitting, we have that 80% of this one, that is 6818 for training purposes, and 1705 for testing purposes. So now let's proceed with our model training. So we will be using XGBoost Regressor. So regressor to SGB XGB regressor. So we'll fit the model. Regressor dot fit our X train and our Y train value. So our model has been fit. So now let's do the prediction on the training data. So training data prediction equal to tracer dot predict X train So now let's check the R squared value. So R to train matrix dot training data prediction will print this R square value. So our R square value is coming out to be 63%. So like 63% of the data of the model is fitting our data set. So let's check the same prediction on the test data. So we'll copy this test data, test data prediction. So X test and R square value, which is our evaluation matrix. So R square train, I will convert it to R square test test, also test. So now I will print it. Our test as well, test. So it's coming out to be around 58%, which is quite good. So this is how the Big Mart sale prediction is being done. That's it from my side. Hope you have enjoyed this video. Thank you.